Hello friends, welcome to the Tech Granth. In the last lecture, we talked about the what and why of the microservice. And in this part, we will talk about the design patterns, the various design patterns that you will use when you will design your microservice. So let's jump into the design pattern that is commonly used for architecting any microservice. So the first one is called a decomposition pattern. So we have a set of patterns and then there are subsets. So one of the kind of the design pattern or one of the type of the design pattern that is used for architecting a system of microservice is called decomposition pattern. And this pattern talks about how you will decompose your project. So if you have a big project, like if you have a project, the example which we took was of Amazon backend. So if you have a project of architecting a system for Amazon backend, how you will decompose that big theory into smaller components, so that those smaller components can be a microservice in itself, and they can be basically maintained separately, and they can be scaled separately, and it follows all the procedure of the mic, or all the it basically encapsulates everything that a microservice should have. So that is what decomposition pattern talks about. And as part of decomposition pattern, we have various types by which you can decompose your microservice. They are by business, by subdomain, and there is also a strangler pattern. So we'll talk in detail about all these three patterns later down the video. So watch the video to know about all these things. The next pattern that we are going to talk about is called integration pattern. So once you have your microservice decomposed, so you have small components, like I'll take the example of again Amazon. So once you have broken down your system, so the Amazon backend system had a lot of smaller service like user service, order service, then a payment service, then there was an inventory service. Now these are all small microservice that has been decomposed based on either business or subdomain, or yeah, basically these two. Strangler will not come into picture in this particular case. And once you have all these services, they have to be integrated together so that they work together to achieve a goal. So to integrate all the microservices together, we use integration pattern, and the various integration patterns are like client side UI, we have API gateway, we have aggregator. So we will talk about the details of client side UI and aggregator pattern in this video. For API gateway, I will create a separate video that will follow up the design pattern video. So do check that out. The third one is database pattern. Database pattern basically deals with how you will use database in architecting your system, how many database you are going to use in architecting your system, and also it deals with how you will basically architect your system for how the database that you are going to use, where you will write the data, from where you will read the data. So all those things comes under as part of the database pattern. So the various subtype of the database pattern are database as a service, data shared database per service, CQRS, and Saga. So we'll talk about all these in details in this video itself. Then we have observability pattern, which deals with the how your services are working. Basically it deals with the metrics, the log, and all those things. So the thing that we will deal with is log aggregation, performance metrics, and exception tracking. So out of these three, log aggregation and exception tracking, these two was basically handled in my previous video which I made on distributed logging. So you can go back and check that video. The description is there, or the link is there in the card there on the top. And we will talk about performance metrics in this particular video. We'll also go through the log aggregation and exception tracking, but it will be in brief. The detail is there in that video, so you can check that out. And finally, we have cross-cutting concerns. So what cross-cutting concerns means is that how you will have your microservice talk to the other service, how you will deploy the microservice, how you will restrict the calls to your microservice. So if an API is bombarded with like a million of call, so how you will restrict all those things. So this part consists of external configuration, service discovery, circuit breaker, and blueprint deployment. For each of them, I will come up with a separate video because these are like a bigger topic and require detailed explanation. So let's jump into decomposition pattern and we'll talk about the various sub patterns that are there as part of the decomposition pattern. The first one is decompose by business. What it means that if you have a big business, so if you have a backend of Amazon and you need to decompose this into smaller services, so you will use decomposition by business pattern. So what you did, or what I did here, was I broke down the backend of Amazon into smaller service like this: user service, order tracking service, inventory service, payment service, cart service, and there was also a search product and a filter service. So these are all small service that has their own goal, and that can be deployed and scaled separately or individually as and when required, and they are broken based on the business that I am going to achieve. So the business is to run a backend which will have a functionality of onboarding a user, onboarding a product, search a product, then buy a product, search for a product, and make payments. So all those functionalities are there, and they are broken down based on the business that we are dealing with. So one service is there which will deal with the user. So for that we came up with a user service. One service is there which will deal with searching of the product. So there is a search product for that. There is a service for onboarding the product. Similarly, for payments we have a service here. And we broke down the order service into two parts, which is cart service and order tracking service. I will talk about this in detail in the next pattern that we are going to talk about, which is decompose by subdomain. So what decompose by subdomain means is that you will break down your service based on some domain, and then it has to be broken down into further subdomain. Now your domain here can be your business as well. So if your domain is a business, then the subdomain will also be a smaller part of the business. And if your domain that you are considering is your architecture, or your infrastructure, or the way in which you are architecting your system. For example, if you are architecting your system in such a way that you have an orchestration, you have some service which will submit Spark jobs, you have some service which will deal with the API call or data ingestion. So overall the domain was the infrastructure, and you broke down that infrastructure or that part of the application in a way, or into microservices, such that orchestration is handled by one service, submission of jobs are handled by another service, submission of data ingestion or handling of data ingestion is handled by one other service. So that way you have broken down your uh, domain into subdomains. In this example, I will take the domain as business, because this is the part which is really tricky and which confuses people between decompose by subdomain and decompose by business. So if you see here, this backend that I designed had a order service, and that order service was broken down into two parts. One was order tracking service, other was cart service. So this cart service is nothing but a part of order service where you can add your order into a cart, and then you basically proceed for payment. So here what business or what domain I considered was order. So ordering business was my domain, and I broke it down into subdomain, and I called it as a cart service and an order tracking service. So I hope this distinction between decompose by subdomain and decompose by business is really clear to you. If you have any doubt, do put it in the comment section. I will definitely answer that. The next pattern under the decompose pattern is strangler pattern. So strangler pattern, it comes into picture when you are moving from a legacy system into a new microservice architecture. So you have this is a brownfield application where you have a big monolithic system, and you are basically transforming that monolithic, or moving that monolithic into individual microservice. So what will happen is that you will not move the complete legacy system into the new architecture altogether. You will pick up few APIs, you will move that into a microservice, and for some time you will run the new microservice and the existing legacy system in parallel. The only difference will be whatever request that has to hit the new microservice will be routed to the endpoint of the new microservice, and the remaining call will go to the legacy system. So for this, what we can do is we can use an API gateway or a load balancer to redirect the call. So API gateway is a good choice here. So what we can do is whenever client makes a request and that endpoint is for the new service. So in the monolith that we had for the backend, what I did was I took out the product onboarding service outside. So I created a new microservice, and the remaining part, this remaining part of monolithic is nothing but this whole architecture. So out of this whole architecture, I took out this onboard service, this part outside. So any call that comes to me or comes to the API gateway for onboarding a product, it will be redirected to this new microservice. The remaining call means any call that deals with user service, payment service, or inventory service, or any other thing or any other component that was there. So everything will be redirected to the monolithic or the existing monolithic that I have. It will be redirected to this application. Slowly, if I moved the payment service out of this, then all the calls to payment service will be moved to the payment service, and the remaining part will be here as part of the monolithic itself. So this is called a strangler pattern because it corresponds to a tree kind of structure where you have a small branch or a small subtree which wraps around the main tree. So here we have this as the main trunk of the tree, and all the new microservice will be wrapped around this monolithic till we decommission this monolithic. So that is what we have, and that is what is called a strangler pattern here. Next, move to the integration pattern. As part of integration pattern, the first one that we will take is the client side UI. So a classical example is again Amazon. So this is a picture of the Amazon's website. So if you see here, we have something for search here. We have something for your accounts and list, something for cart, return order, and also we have some pictures here which are clickable. So you can click here and you can go to AC, you can click here, go to the list of washing machines that are available for sale. So what it denotes is that on the UI side you have just one screen, but there are multiple microservices that is running on the background. So if you write something here, it will hit a microservice which will search a product for you. If you click here, it will redirect you to your account, and you can deal with all the things that are relevant to your account. So you can create a profile, add phone number, email address, and all those things. So this will deal with your user service, this will deal with your cart service, and same thing goes for all these. So these will go for product search like this one. So that is how you have integrated so many microservices which is running on the back end using just one screen, and that is what is called a client side UI. The second one is the API gateway, which we'll talk in detail in the next video. And the third one is the aggregator. So aggregator pattern is a pattern where you have decomposed your microservice into multiple smaller service. Each service will have its own database, or some can have a shared database. Now suppose you have multiple service which has its own database, and you want to pick up the data from each, means from two service, and then you have to aggregate the result that you are getting. So let me take an example here. This might not be a classical example or an example which you will implement, but this is just for explanation purpose. So suppose you had a service for pricing and you had a service for commission. Now at the end of the day, when client makes a request, you need to return price of certain object. The price of that object will be whatever the price that you get from the pricing service. On top of that, there will be some commission that will be added into that. So it can be a tax or anything else, means it, you can think of it as an add-on to the price. So finally the addition of these two has to be returned. So that is where this aggregator can come into picture. So it can be a microservice in itself which will make a call to pricing service and commission service, aggregate the price and send it back to the client. Or you can also use an API gateway here. So if I try to relate it to a real world example, you can think of it like a trading service. So if I have a trading service here and you want to trade internationally, so you will basically go to the trading site of America or India, and finally you will have there will be also a service which will be there for for conversion of your currency. So final price that you get for any share will be whatever share you get, and whatever is the conversion price for that particular share. You pick up these two data and aggregate it at your aggregator service. So this is the high level of how the aggregator pattern work, and this is very straightforward. Let me know if you have any doubt regarding this. So these are the these are the integration patterns that we are using as part of our microservice architecture. The third broad classified design pattern is the database pattern, and the first one for that is database per service, which is self-explanatory. It is pretty easy. So you make a call, and for each of the service that you have created, each of these service will have their own database. So there will not be any dependency between these two service. It will not happen that product service will have some data lying in the database of user service, or user service will have some data lying in the database of product service. So this one is pretty self-explanatory. Database per service means that each service will have their own database. The next one is shared database per service. It means that multiple service will share the same database. So although database per service seems very good or seems very easy, but in a real world, in most of the cases, you will end up using a shared database per service. So in this particular scenario, what you will do is, like, if you have microservice which have related kind of data that you are dealing with, so you will put it in the same database, and you will query from the same database. So that is what shared database per service is. The third one is command query responsibility segregation. So as the name suggests, that there is a segregation between command and the query responsibility. So there will be a database which will be responsible for command, and there will be a database which will be responsible for your query. What does command means? Command means that anything that modifies your data is a command, like an insert, delete, or an update. So it comes into play when you have to join data from multiple service, as you have implemented database per service pattern. So it means that you have multiple services, each has their own database, and now you want to aggregate it, and when you aggregate it, you need to get data from both the places, and you also need to basically show that data. Now this statement will get little confusing with aggregator pattern, but in case of aggregator pattern, we just used to get the data, join the data, and send it back to the user. But in this particular case, we have to design the system in such a way that there is the load is divided between the two database. One database where you have your command, which will be that database per service pattern. So each service will have their own database, and you have to add one more database from where the query will happen. So what we say here is that we segregate the responsibility of command with the query. So create, update, and delete, this will happen on the respective database per service. So if each of the service, like in the previous example, there was a service for your user service, there was a service for your product or inventory service. So each of the update, delete, or anything that modifies your data, those kind of command will be happening on their respective database. Means respective means each service that has their own database. So all the command will be all the command will go and it will hit that particular database individually. Whereas when you have to read the data, in that particular case, we will create another database, and that database will be a read-only kind of database, which where we'll create a materialized view. So what this view will do is that this particular view will have read-only access to all these database or the table of these database, and you can basically join all these table as part of this materialized view creation. And these materialized view can be updated, or it can be basically this materialized view needs to be updated as and when the command happens. So let me show you an example here. So this diagram was taken from microservices.io. So what it shows is that you have order service, kitchen service, delivery service, and accounting service. So these service has their own database. Each of these service has their own database, Now, as and when some update happens to delivery service or kitchen service, an event will be triggered, and this will be triggered to an aggregator. So you have an aggregator here, order history service, and there is a database here. So this database is nothing but this database will have the materialized view that we were talking about, and this materialized view will be updated, and this materialized view will be updated as and when this event is fired through this event handler. So if delivery service, there is an update or delete or create on delivery service, an event will be fired, and it will say that okay, if there is any materialized view which deals with the table which I have updated just now, you update that as well. So that is how this update will happen. And all the query like find order history or find order, that will be served from this particular database. So you have a segregation here. So all the command, the create, update and delete will happen on the respective database of each of these service, whereas the query will happen from this database, which is for your query purpose. So this is what your CQRS is, or command query responsibility segregation pattern is. Now let's deal with Saga. So the next pattern for the database pattern of microservice is Saga pattern. So this comes into picture when you have a transaction which spans over multiple service. So each of the service has their own database, but the transaction is such that you update few things. The transaction is basically a distributed transaction. So you have to update certain things on one database, and once that is updated, you go ahead and update a certain table on the other service. So it is a sequence of transaction that can happen on each of the DB locally, and in case of failure of one service, the Saga should reverse the transaction in other service also. So since it is a series of transaction, if one of the transaction has failed as part of this, then all the transaction that happened, it has to be reversed basically. So that has to be done. So there are two ways in which you can implement Saga. One is choreography, the other is orchestration. So orchestration and choreography, if you see, these two are different in a way. You can relate these to the orchestration can be related to the orchestra that is there. The term comes from there only, where one guy is there which will control all the service. So as part of the orchestra, there is just one guy that will give signal to the member of the orchestra who has to play what and what kind of pitch they should play and all those things. So in case of orchestration, what will happen is, for the transaction, suppose there is a transaction that will update something in service 1, then on service 2, and then on service 3. So in case of orchestration, what will happen is orchestrator will say that okay, go ahead, update it in service 1. Once it is updated, a response will go back to orchestrator, and orchestrator will go ahead and it will say that okay, I have to update it in service 2. Now in case there is a failure while updating or inserting something in service 2, orchestrator will have the responsibility to go back and tell service 1 that my transaction failed in service 2. So whatever transaction I did as part of service 1, you roll back that transaction, because that is not an atomic transaction, or that transaction is not complete. So that responsibility lies with the orchestrator. Whereas in case of choreography is like you have 3-4 dancers who are dancing together. Each of the dancer will have their own responsibility. There will be no lead kind of thing there. So in this case, what will happen? Service 1 will do its work, and it will then say that my work is done. Now this will call service 2 saying that my work is done, you go ahead and do this transaction or complete this transaction. It will say the same thing to service 3 also. And suppose if service 2 has updated the record and service 3 the transaction has failed, in that case it will go back to service 1 saying that my transaction has failed, and then service 1 has to send back, or it has to handle that, and it has to send a reversal of the transaction to service 2 also. So that is how the choreography will work, and these two are classical example. Both are used immensely in anywhere you are using microservices. The third one is, or the fourth one is the observability pattern. As part of observability pattern, we have log aggregation, we have performance metrics, and the error tracking. So those two I told you, I have created a separate video as part of the distributed logging. I'll just go in brief after this. So we'll talk about performance matrix here, what we do as part of the performance matrix. So what we can do is, like similar to the logging, we can capture matrix centrally. So if multiple microservices are there, so we can capture the matrix from each of the microservice, and these matrix can be any kind of matrix, like load on the system, or it can be customized matrix like how many rows are processed, or how many transaction happened as part of 1 day, 1 hour. That kind of matrix can be there, and these can be centralized. So we can have a push or a pull mechanism where a system can pull from the each of these service, or those service can basically put it in some queue, and you can have a service which will pull the data from the queue. So you can have both of these things. The next thing is that you use application which helps in instrumentation. So this is again an example. If you are familiar with Java Spring, so Spring provides actuators which will give you slash actuator, and you can go and read all the metrics of your service that you have created. You can also have the custom utilities, and yeah, basically these are the things that you can do as part of your performance matrix. And the idea here is that you have to design your performance matrix application in such a way that the load is very less on the system, or the load is very less on the services that are running as part of your application. And finally, we have the log aggregation and exception tracking. So if you watched my last video on distributed logging, you will be familiar with this diagram, where we have multiple service and we have a distributed queue, and each of these service will put an event in the queue. So go there and check out that particular video, and you will be familiar with the log aggregation. So that is it for the design pattern part. In the next part of the microservice video, I will come up with the API gateway, because I don't want to prolong this video for too long. And subsequent to the API gateway, we'll have the other cross cutting technologies like service discovery and blue-green deployment and everything else. So do let me know in the comment section if you want me to add anything else. That is it for this video. Take care. Bye.